A crate hangs from a rope that is attached to a metal ring. The metal ring is suspended by a second rope that is attached overhead at 2 points as shown. What is the angle theta if the tension in rope 1 is 1.08 the tension in rope 2? Our first thing we have to understand here is that the rope number 2 is going to pull both directions. You can see how it's sort of pressing on both sides of the ring, so that's nicely drawn. And that's going to exert essentially a tension both ways. So when we draw our free body diagram, it's going to look something like FT, let's call this FT2 pointing that way, and FT2 pointing that way, and then FT1 pulling down. And we're given that FT1 is 1.08 FT2. There are a couple ways to solve this. I think the most general and direct way is to just get the components. So we're going to remember that we can always break any vector up into its components. So I can make my free body diagram instead look something like this. That the left rope has F2y pulling up and F2x pulling over. The right rope has F2y pulling up and F2x pulling over, and of course F1 is still pulling down. And we could get F2y and F2x if we need to from using trig, and we will do that at some point. Then we can say, well, because it doesn't move, we know that the net force is 0. There's no acceleration going on, which means the net force in every direction is 0, which means the net force in the y direction is 0. The net force in the y direction would be F2y plus F2y minus F1, and that has to be 0. Now we need to actually find these things. So I'm going to go over here and I'm going to say, let's take FT2 and we know that's theta. We want this bit over here, which I've called F2y, and we know the full length, which is FT2. So doing our trig functions, we want to do cosine of theta is F2y over FT2, which implies that F2y is FT2 cosine theta. We can go back into the other equation then, and we'll have something like F2 FT2 cos theta plus F2t cos theta minus F1 equals 0. Let's see if we can create some space for ourselves. We, of course, can go on and then say, well, this is 2ft2 cos theta. That's just adding this to this. And then we subtract 1.08 ft2. And this bit comes from the given bit that ft1 is 1.08 ft2. All right. And then we just keep processing. Notice in so doing that we get an ft2 in both terms, so we can factor that out. 2 cosine theta minus 1.08. If two things multiply to 0, one of them is 0. It clearly makes no sense. This can't be 0, so I can divide it out. I'm left with 2 cosine theta minus 1.08 is 0. 2 cosine theta equals 1.08. Cosine theta equals 0.54. So then we can say, theta is the inverse cosine of 0.54, which turns out to be 57.3 degrees. This corresponds to what they listed as the answer, so yay, it's right.